Okay, let us talk about exponential functions. Here we go. Exponential functions. So we're going to go over a little bit of basics of different types of exponential functions. In general, remember that we define an exponential function f of x to be a times b to the x. Okay, a and b are both numbers. A is a number, they're just the coefficient. B, however, is called the basis. This is the base. This is another number, but it is the base. Remember that when you're dealing with exponential functions, the exponent is a variable. The exponent is x. In physics, or when you're in calculus class, or if you want to use a different variable, you can represent t as independent or free variable. It has the same meaning, a, b to the t power. Remember that x belongs to b. A is a number which is outside. B to the x is the basis, and x is the power of the exponent. I'll give you some example. Let's take a look at a couple of examples and try to graph these examples. Well, suppose you have f of x equals to, I'm going to give you 2 to power x. I'm not giving you any coefficient. Remember that the coefficient here is invisible, so a is equal to 1, and b, the basis, is equal to 2. Okay, so this is an exponential function. I expect you to ask, so what's the graph like? What's the domain? What's the range? How to analyze this function? Let's try to graph this guy without using a website. Just try to use a table, give different values to our x, calculate y at those x values. Okay, very good. I have my x, and I have my f of x. My y value is 2 to the power x. Okay, let us start. Plug in any number that you like. Let's plug in 0. Am I allowed to plug in 0? Let's check. I have 0. I have 2 to the power 0. F of 0 or y value is 2 to power 0. Remember that any non-zero number raised to 0 is always 1. So what's the meaning of that? It means that the point with first coordinate 0 and second coordinate 1 is on the graph. Very good. Let us plug in some positive numbers. Like what? Like 1. My x is 1, so f of 1 is 2 to the power 1. 2 to the first power is nothing but 2. So what's the meaning of that? It means that the point with first coordinate 1 and second coordinate 2 is on the graph. Okay, so far so good. Guys, remember that this is not a linear function, so we need more than 2 points. Let's plug in a negative number, -1. My x is a negative number, so my f of -1 is 2 to power -1. Well, I don't like to have negative exponents. So what's the meaning of 2 to the power -1? It is 1 over 2. Recall that from algebra. I recall for you. A to power -1 is 1 over a. A to power -n is 1 over a to the n. And if you have a over b to power -n, it can be written as b over a to power n. So these are from your algebra. From algebra, I have the following scenarios. Well, okay. So far, so good. I have -1 and a half as its y value on the graph. Okay. So graph it for us. Sure, why not? We have 3 points. 1, 2, 3 points, and I'm going to graph this function. Take a look at this graph. So here I have my x-axis, I have my y-axis, and at 1, I have 2. 1 and 2. At 0, I have a 1. It means that the graph hits y-axis when x is 0. -1 and a half. -1 and a half. Well, let me connect these together. I get the graph as if I continue plugging more values, I'm going to have a better visualization of this graph. This graph is an increasing graph from left to right. 2 to the x is increasing. The graph is an increasing graph. From left to right, the graph goes up. Note that the base is larger than 1. Just a quick note. The base, B2, is larger than 1. Okay, keep this going. Take a look at this. Now we're going to change the bases to a fraction between 0 and 1. Okay, now let me change the base. I'm going to change the base to a half. And I want to see what is the observation that I'm going to have. Now take a look at this function. Here you have a half to the x. Sometimes they do not use parentheses. They just write it as a half to the power x. But if you see something like this, it doesn't make sense. Put that in parentheses. A half to the x. Another standard way to write this down is 1 divided by 2 to power x. Or if you open a different book, you might see 2 to power minus x. So if you don't want to use parentheses, make sure that you have a negative sign next to your x. Very good. So in this case, suppose I try to graph this guy. This is my x on the left and a half to the power x on the right hand side. These are your y values. Let's plug in different values for x and evaluate the function. If x is equal to 0, you have a half, you have a number to power 0, which is just 1. Okay, so far so good. Let me plug in a positive number, like 1. If I plug in 1, I get a half to the first power, which is equal to a half. If I plug in -1, I get a half to power -1. Remember, having a negative exponent, you're going to flip your fraction and have a positive exponent. You get 2 divided by 1 to positive exponent, which is nothing but 2 to the first power, or just 2. But what's the meaning of that? It means that 1.5 is on the graph, 0 and 1 is on the graph, -1 and 2 is on the graph. So let's graph this guy. Let us use a different color for this. It says at 1, I have a half. At 1, I have a half. At 0, I have a 1. 0 and 1. At negative 1, my y value is increasing. I have a 2. If I connect these together from left to right, remember that we read graphs from left to right. From left to right, the function is decreasing function. So if you have a half to power x, you're going to have a decreasing function. Remember that b, or the basis, is a half. A half is in between 0 and 1. Very good. So this is our observation so far. Based on our observation, we can write a nice conclusion. We can say that, hey, as long as I have an exponential function, if the basis is larger than 1, the function is increasing, or I have a growth function. If b is sandwiched between 0 and 1, the function is decreasing, and I have a decay function. So these are the properties for exponential function. As you can see, in either case, the domain is between negative infinity to positive infinity. So the domain, negative infinity to positive infinity, or as you remember, the bolded letter R representing the real line.